All right, sorry I got cut off there. So let's go ahead and just move on to this section. We're finding the missing perimeter and areas of each of these figures. So we have our two side lengths to compare. So let's just call this figure the new one and this one the original one. Usually I just say the one on the left is the original. Okay. So for our ratio or our scale factor, our ratio we would say is 28/8. Okay, now both of these can be divided by 4. So if I want to simplify this, it'd be 7/2. So 7/2 would be our side length ratio and our perimeter ratio. So I'm going to take this 7/2 and I'm going to set it equal to the ratio between these two sides. Now, when I put 28/7, I was comparing from the larger figure or the new figure to the original. So I want to compare it in the same way for the perimeter. So let's set up 7/2 and let's equal that to the perimeter, which is what we're solving for here, over 28. Okay, now from here, all you have to do to solve for the missing perimeter of the larger figure or the new figure is just set up a cross product. So multiply p times 2, so 2p, multiply 28 and 7, and then just divide by 2, okay? Now for our area ratio, the only difference is, now remember, perimeter ratio is the same as side length ratio, but if we're looking for our area ratio, we actually need to take 7/2, and we need to square that. Okay, so that's going to become 49/4. All right, so now we can take 49/4. We want the area ratio if we're solving for missing areas, 49/4, and we're going to set that equal to, we're going to go in this direction as well, 294/A, or the question mark. And then here you would just do a cross product as well. Okay. Whoops. I think I have something else playing in the background. Let me close that out. Okay. Thank you for your patience. I'm not going to stop the video every time something happens like that. Just going to keep going. Okay, so we have our perimeters. We have 56 and we have 28. So our perimeter ratio could be 56/28. So you can simplify that. Now, whatever you get for that, 56/28, you can set that equal to 16 over this missing side length because the ratio between those should be the same, okay? So 56 and 28, that actually simplifies to 2/1 or just 2. So you can take 2/1 and set it equal to 16 over question mark, right? So it looks like a ratio of 2, so it kind of would just be half the size. So if this is our ratio of the sides, the ratio of our perimeter, that means we're going to take 2/1 and we're going to square it, or I guess you could just use 2 as well, and that would be 4/1. Oh, let me move this over to the side. My face is covering that. So we have a ratio of 4/1 now. So what we can do is we can take that 4/1 and we can set it equal to 144 over the missing area. Okay, so I'm just keeping it as a ratio of 4/1 because it just makes it easier since we're using a ratio here instead of just using 4. And then you could just do your cross products to set that up. Okay, now on the bottom of the page here, we are looking at just finding ratios between, we have the sides. So make it easy. Let's just call this the new. Let's make this one the new. Let's just say it's getting smaller so that we're not always doing the same thing every time. And then let's make this one the new figure. Okay, so I'll do one example with you and then you're going to try the other two on your own. So the new over the original is 5/4. That is the side ratio. I know it's not asking for that, but we need that. That's also the same as the perimeter ratio, P ratio. Remember, these are always the same. And then our A, our area ratio, is this value squared. So this would be 25/16 in simplified form. So you're going to set that up similarly for these problems here as well. You have some extra information. So we just need to know what side does 3 match up with in this diagram. Is it the 8 or the 5? And then similar over here, what side does the 4 match up with? Does it match up with the 3 or the 4 if you were to maybe rotate it around? Okay. Now let's move on to page 18. Let's see. All right, so now we are finding the similarity ratio for each of these figures, okay? So we have an area ratio here of 8/32. You can set it up as 32/8 or 8/32. Let's do 38 or 32 over 8, because I know that simplifies to 4. So this is my area ratio. Now, I know an area ratio, basically I take a regular ratio, and for area, I take that and I square it. So from here to here, I'm squaring my value. But the opposite of squaring a number is taking the square root. So if we want to know the similarity ratio, we would have to take the square root of 4. So our similarity ratio or side length ratio is kind of the same thing. Scale factor, also the same thing, would be going backwards from being squared to not being squared. So that's the square root of 4, which is 2. Okay. Two squares, they have an area of 81 and 25. Actually, for this one, it might be kind of nice to just kind of visualize if we had a square that was 81 and we had a square that was 25, what are those side lengths? And then you're just kind of giving the ratio between the side lengths. And that should also show you, oh, okay, well, yeah, the area is a squared value, and then I'm taking the square root of that to find the side lengths, right? So what numbers would go here and here to multiply to make 81? What numbers would go here and here to multiply to make 25? And then here we have a triangle with area of 10 and 360. You can set it up as 360 over 10. I would simplify that first, and then you can take the square root. Same thing will go with this question. And also keep in mind, you're going to have a pi divided by pi. Well, think about what happens when you divide a number by itself. Pi divided by pi, that should simplify, and you'd be left with 1. So really then we're just looking at the 128 and the 18 when we're comparing them. Okay, and then for the problems down below, let's see, I'll do maybe one with you here, number 8, and then I'll do maybe 11, and then you're going to try a few on your own. So it looks like here we have a side length ratio of 12 and 5. Those are our side lengths. So I'm going to go ahead and put 12 over 5. Now what I'm solving for is a missing area. So I need an area ratio. I can't just use this ratio of 12 over 5. So this is the area that I'm looking for. This is my question mark. So I can't just put 12 over 5 equals A over 20, because that would just be a side length ratio. That's what we did with similar triangles. That won't work. So what I need to do is I need to take this and square it so that it's in the proper ratio format. So this would be 144 over 25. Okay. Now that I have my proper area ratio, okay, I'll just put an arrow here. Now I can set that area ratio equal to whatever this area is. We don't know it. So I'm going to put A over this area here. I'll put 20. And then from here, we can just go ahead and do a cross product. So 25 times A, that's just 25A. And then 20 times 144, that is 2,880. And then I would just divide by 25 on both sides. So the area of this smaller figure is 115.2. So that's what I got. And then it would be inches squared. Okay. Now for the last set of questions, you're going to try these two on your own. The last set of questions here. Let's look at number 11. We have our two areas given to us, and we are finding the ratio of the perimeters. Okay, so area 27, we'll compare that with 12. You could also put it in the other format as well. I always like to try to simplify this first before I take any square roots, because if I simplify 25 and 12, well, what goes into both of these? 3 goes into both of these, right? So 27 divided by 3 is 9. 12 divided by 3 is 4. So this is the area ratio, essentially. Now remember, area ratio, in order to get into a side length ratio or perimeter ratio, we square root that. So if we square root that, that would be 3 over 2. So hopefully that helped you complete pages 17 and 18. Please join us for office hours if you have any further questions.